So, same thing today that we do every day. What did we learn?
Avogadro's number.
Avogadro's number. What exactly is Avogadro's number?
6.022 times 10.
Now, if we listen to my question, I never asked you what is the value.
What mole?
Atoms per mole.
That's the number of atoms
Per mole.
per mole
Per element.
of an element.
There you go. Okay? Avogadro's number represents the amount of atoms. Is it only atoms?
Molecules.
Atoms, molecules, or ions that you have present. Avogadro's number is also equal to 1 mole of these things. Okay? The value is 6.022 times 10 to the 23rd. What else did we learn?
Conversions from moles to molecules.
Conversions from moles to atoms, and what else? Grams to moles. How do you convert grams to moles? What do you need? The who? The molar mass. What are the units for my molar mass? Grams per mole. If you're going from grams to mole, how do you set up your molar mass conversion? What goes on top? What goes on the bottom? Grams on. So we're going from grams to moles. So in the conversion factor in the middle, how do we set up our molar mass?
Mole or grams?
Yeah, but where?
Moles.
Moles on top, grams on the bottom. Okay? How do we go from moles to atoms?
Moles multiplied by Avogadro number and divided by 1 mole.
There you go. So you have moles. Your conversion factor would be Avogadro's number on top and 1 mole on the bottom. How do we go from grams to atoms?
It's gonna be the same way.
We have the long way and we have a shortened way. What's the shortened way?
Like some on the top,
Atoms on the top.
and then the value
What's that called?
molar mass.
Your molar mass is on the bottom. Why can you do that? Yes, you do.
It's the same because it's 1
Per
1 molar mass equal to the number of Avogadro's number, like the atoms, number of atoms in a molecule.
We're missing something. It does, the molar mass is equal to your number of atoms, but what else is it equal to? What is it called? Loud and proud. With equals to 1 mole. So you can substitute your molar mass for your 1 mole. Right? Now, how do we go from molecules to atoms?
It's the same.
Oh no, the
Oh,
atoms
no, not.
multiplied by the amount of molecules in the compound. It's like, say for instance, like on a homework it was like, I don't know, I'm making something up.
You are making stuff up.
C280, this is made up. This is
Okay.
ours. But then it's multiplied by 7, because it's like 7 total.
Okay.
7 total molecules. From the
You
compound.
use your right terms.
Is it atoms?
You have,
But the subscript is that not molecules or is that atoms?
no ma'am, that
So
is
the
atoms.
subscript, but I thought the subscript when you say it out loud is like you say 2 molecules.
No, that is your coefficient. Your coefficient and your subscript, 2 totally different things.
Okay.
Your coefficient right now would be, no, it's, your coefficient now is what? We have transitioned into moles. So your coefficient is now moles. Alright? So your coefficient reads as moles, but your subscript will always read as atoms.
So you multiply by the number of atoms total.
Right, so let's say if I would give you 1 mole of water, okay? I would ask you how many atoms are there in 1 mole of water.
Get the molar mass first.
You have the molar mass,
Then times it by the Avogadro's number.
times it by Avogadro's number, and that will give you
Number of atoms.
the number of atoms. But now, if I ask you specifically, how many hydrogen atoms are there in 1 mole of water?
Subtract the oxygen part.
No subtract the oxygen part.
The two
You're going to multiply by 2 because you have 2 hydrogen atoms in there. Okay? You have to be able to manipulate these things to find what you want.
Say it one more time, please.
You have 1 mole of water. I want to know how many hydrogen atoms are there in 1 mole of water.
For what? What compound?
The water.
For water. I didn't know what you said.
You heard me say water?
Alright.
Mm-hmm. Madam Sicky.
So
Okay.
how are you doing that? It's 1.
Okay. Listen. You have 1 mole of H2O. I want to know how many atoms are there in 1 mole of H2O.
How many atoms?
How many
What
atoms?
moles to atoms?
Hmm?
2.
No. Listen to what I'm saying.
Don't care.
How many atoms are there in 1 mole of water? 6 point. You can't tell me 3. Like that's in 1 molecule of water. 1 molecule has 3 atoms. In 1 mole, how many molecules are there in 1 mole?
Oh, 6.02.
6.022. Okay? But now,
You said in water, now you want to know for hydrogen.
right, so we're going to take this over. Let's see. What am I doing here?
You need to do a conversion for moles.
6.022 times 10 to the 23 molecules. 1 mole. So you have 6.022 times 10 to the 23 molecules of water. Alright? So now I want to know how many hydrogen molecules are there. So this is molecules per mole. Right? So now, how many atoms of hydrogen are there?
2.
2 times 2. 6.2.
No 6.0 times 2 to know.
It's only 2 atoms. 2 atoms of hydrogen.
2 multiplied by 6.
In what though?
And
One mole. One
No.
molecule of water.
There you go. So you have 1 molecule. No, you didn't.
I said in water. Okay. I did.
You have 2 hydrogen atoms. So now you can multiply that over and you get how many hydrogen atoms you have in 1 mole of water. What you knowing about?
Continue.
I hate this 12.
Well, you tell me what it is.
It's 12.
It's 1, 4,
Oh, you-
2 in
1
mole. Professor, is it different? I'm kind of confused between atoms and molecules.
Okay. Tell tell me what in here, which is the molecule. What is a molecule as a matter of fact?
Molecule.
Like compound. Okay, how do you define a compound? I'm missing something.
Like a chemical.
Starts with a D and an I. Who said it?
Different?
You have two or more different atoms coming together. You got to know that. If they're the same, what do you call it? A what? An elemental compound, please and thank you. Yes.
I need that.
So you're going to multiply this number
Times 2.
by 2.
Yeah, so you got 1.2?
Yes.
10 and 10, 24.
Oh, you gotta do the whole base.
So you just,
So now, if I were to ask you how many atoms in total are there in this many molecules of water, you have to multiply this by 3 instead.
So
Yeah.
the test, like we have to write it down like that.
Yes.
So how does it even come to point?
Okay.
Right? Because on the final, if you don't show your work, but you give me the right answer, you get no points. Even if you leave your working on your scrap paper and it's beautiful, I cannot grade that. Okay? Questions, comments, inquiries? Yes.
So then there was another question with like, if it had, I think it was this much grams, is basically like that?
Yes, so if you start out with grams and you want to end up with atoms or molecules, you could do the same thing.
Professor,
Yes.
if it's going to be how many atoms of water? So we multiply by 3, right?
Yes.
You said. But what does it mean then if we convert it from moles to, like moles multiplied by Avogadro number? It's atoms as well.
Atoms, molecules, or ions. It depends on what they're asking you.
Like for example, it was example for 1.5 or something multiplied by Avogadro number divided by 1 mole. What is that?
Okay, so but what is the something in the front? You tell me 1.5 of something. So that'll give you atoms. If you said Avogadro's number?
Yeah.
What's the units attached to Avogadro's number? You have to have a unit attached in order to know what they're asking you for. What are the 3 units for Avogadro's number? Atoms, molecules, and ions. So you have to specify what you want. Right? Well, you would have to, they would have to give you the questions in ions.
It would have to be an iron compound.
No, it would have to be an ion. So I can give you K+.
Gotcha.
On the homework, it asks like for, well, the question said, I had to write it down.
Okay.
Complete combustion of 5.20 grams of a hydrocarbon produce 15.9 grams of CO2 and 7.81 grams of H2O. What is the empirical formula for the hydrocarbon?
Okay, so
You would have to take each value, like the percentage, and you divide that by the total.
Ain't no percentages
For
here.
the molar
Huh?
Ain't no percentages here.
Well, the value that they give you it should be like a percentage, right? Or is it just?
they give you grams,
Oh, okay.
all right? So you need
And
to
you
figure
divide
out,
that by the molar mass of that element.
no, not of the element first, of the compound.
First.
Then you can translate that into specific amount of atoms that you have in that weight. So let's say if you have 10 grams of CO2 that's produced, you convert your CO2 you convert your grams to moles, And then you can figure out how much of that weight is contributed to carbon.
And the smallest value is when you divide everything else by?
Yeah, so you can find the ratio.
Yes, so, because it's an empirical formula.
Yes.
Yes.
I have a question. So specifically, when do you need to use Avogadro's
It's
number? Because
When they're asking you for atoms, molecules, or ions.
so when they ask you for grams, you don't have to use the number.
When they're asking you for grams,
The mole of like for example, last class you said calculate the number of moles of sulfur atoms in 98.6 grams. So we don't use the Avogadro.
no, because they're not asking you for how many atoms are there in these grams. They want to know how many moles are there in your 98 point something grams. Okay? What else? We didn't finish what we learned. We don't sidetrack and take over tangents. What else did we learn?
What was it? How to find the empirical.
How to find the empirical formula. What's my empirical formula? The simplest ratio of atoms in your molecule. Good. What are my steps to find my empirical formula? Step 1.
Convert percent to mass.
Convert your percentage to mass. How do you convert your percentage to mass? You grade everything out of 100 grams, so what do you do with your percentages? You just take all your percent and put your grams. Step 2.
Convert mass to moles.
Convert grams to moles. Step 3. You divide it by the lowest moles. Step 4.
Round the numbers.
No, well,
Step 3 does not have.
if you don't have
Give a whole number.
whole numbers, you can round. What is my rules for rounding
It has to be.
with empirical
It
formula?
has to be one. Is it 2.1?
It has to be 1.9 either, or.
Not 1.9, but it has to be 0.1 away from a whole number.
That's what I was saying. Why you gave me the face?
You think you didn't say that? You said 1.
0.11, you know what I was trying to say.
You I don't speak Monique yet. Okay?
That's what I was
So,
trying to say. It was.
So if you are not 0.1 away, what must you do? If one of your values is not 0.1 away, what must you do? What do you mean lowest number?
Multiply by the smallest number and each number by the lowest moles.
I only roll multiply by the smallest number, which I can get to finish.
You're going to multiply by the smallest integer or smallest number that is going to give you a whole number or a number 0.1 away from a whole number. Alright? So let's say, for example, if you had 1.25, what are you going to multiply by to get your whole number? 4. If you multiply 1 by this integer, what are you going to do? If only one of them is not 0.1 away, and you multiply that number by your integer to get you to your whole number, what must you do?
Why you choose 4?
Alright, bet. You have 25 cents. Or you get $1.
4 more, 3 more.
Multiply by 4.
Wait, but you already have 25?
Yeah, you have 25 cents. How you just get $1?
Okay.
You get it? Sure? Sure line?
A little bit.
See? Stay line. I can't with you, man. So again, if you have your one of your number is not 0.1 away, and you multiply that number by an integer to get you to your whole number, what must you also do?
Do everything else.
Multiply everybody by that same integer. You must do that.
after finding divide last number.
What? I don't know what you're writing. So once you get your whole numbers, what do?
Oh, you set up the, the thingamajig.
You write out your equation.
7, okay.
Alright?
Wait, but there's something I did here that I don't understand what I did. Why I divided by this number here.
I know what you're What?
After you find the grams, whatever.
Right, so that's you divided by the lowest most.
Okay, so that's the last step, divide by the lowest.
Right, to get your ratio.
Okay.
Now, how do we go from empirical formula to molecular formula? What do you need
The magic number and
before that?
molar mass.
Empirical mass.
You need your empirical mass. What else? You need your molar mass or the molecular mass, the mass of your molecular compound. That will be given to you. How do you find a magic number? Divide what by what? Molar mass by empirical mass. That gives you your magic number. What do you do with this magic number?
Multiply the number of grams.
You multiply by all the subscripts in your
Empirical.
formula. Good. What else have we learned? Was that it? That was it?
Wait, so
Different reaction. What, tell me?
what is the empirical math?
You have to calculate that.
Oh, like with these numbers?
How do you calculate your empirical mass or your molar mass? How do you calculate that? What's the steps for that?
The empirical mass,
Mm-hmm.
the molar mass,
Mm-hmm.
you add up all the elements.
Give me more than that.
You have H2O, you add 2 hydrogen atoms, elements, 2 hydrogen atoms and 1 oxygen atom.
So that gives you 3 atoms.
No, you add up the weights of each
You
atom.
add up the atomic weights of each atom. Okay? That gives you your overall mass.
But what about the molar mass? Will you provide us?
I said I'm going to give you the molar mass like 5 times now.
And then
She first.
Oh,
Tell me.
When you said atomic weight, right? Is that the same thing as like the combined molar mass?
No.
So what's
Atomic weight is each individual one. What's the atomic weight of hydrogen?
is that the molar mass?
-2.
One gram.
We pass AMUs.
1 gram per mole.
Gram per mole. 1 gram per mole.
It's the same thing.
Same thing as your molar mass of hydrogen. 1 gram per mole.
That's what I said. Combined molar mass
No. Combined molar mass.
would be.
That word combined means you're adding everybody up.
Okay.
So you have to just say your atomic weight or your atomic mass or your molar mass
I'm just looking
of
at
a
one.
particular atom.
I'm only looking at one element.
Yes.
Okay.
But you also have the molar mass of each element, and you also have the molar mass of the compound as a whole. Okay? So
you
molar,
use that for the empirical. You just use
the empirical mass. You gotta use
atomic weight, you said.
Well,
What
which
is
one?
atomic weight?
That's what you find on the periodic table
Okay, that's it. Which is the molar mass.
of that atom, not the molar mass of the entire compound.
No, exactly.
Okay. Yes.
what was I gonna ask? So, the mass of the empirical formula is like, when you have the example C7, then we would have to do 7 times what C is.
Yes.
And then for all of them, then add it up.
Yes.
And that's the empirical formula.
That's
Okay,
the
for
empirical
this
mass.
mass, yeah. For this one, how come this one is not up to the whole number? What do we do for this one?
You converted the mass that was given to moles.
Yeah, but what did you say about the whole number again? Because this isn't the whole number. We didn't do anything for this.
Right. So that top one here.
Mm-hmm.
Okay. You converted this mass to moles, and you get this moles.
Yeah.
So now the next step after you've converted your mass to moles is to figure out which one has the lowest moles. So look at this one, that one, that one, that one, which is the lowest.
This one.
So now you divide everybody by this to get your ratio.
Oh, and then after, if when you divide all of them, if this
Right,
is a whole number,
right,
then okay,
right.
okay.
Right? What else? The types of reactions. What are my 5 types of reactions?
Combination.
Combination, decomposition, single displacement, double displacement, and combustion. How do we recognize, okay, combustion, how do we recognize combustion?
Isn't it when compound and oxygen gas?
What kind of compound?
Carbon, CH,
Oh yeah, it has to have a carbon.
A hydrocarbon.
A hydrocarbon. What's a hydrocarbon?
Hydrogen and carbon.
Hydrogen and carbon bound together. So you have a hydrocarbon reacting with oxygen to produce
Is it oxygen gas?
oxygen gas, sorry.
produce water and something else. I forgot what it was.
Carbon.
Oh, CO2 in water.
There you go.
But then what I learned yesterday doing my thingamajig for number 6 is that some of the yeah, the thingamajig you did, it said that, you know, some of them could be both. The one with it's oxygen and magnesium or sulfur and oxygen or something like that. It could be both. That's not what it said.
both.
No.
That's what it said earlier.
In the
It's
lab.
actually in the lab manual.
She said the
It's in the lab manual.
It's in the lab, but that's what I'm gonna read though. That's what I read.
What? There's something that we said. Now the reason that in a true combustion, what must you have?
Hydrocarbon.
A hydrocarbon and oxygen gas. Now, what is the third product of a combustion?
Carbon dioxide.
No, that's the first one.
Water, right?
Explosion?
Well, what is that though?
Fire.
Fire, heat.
So then that one was just the combination.
That's just a combination.
So then if I
So why?
They don't be whiting out my lab report. Okay? So again, the main thing with a combustion reaction is that you must have a hydrocarbon and oxygen gas. What you also have is the release of energy. The release of energy, when we get to chapter 5, you will see the types of release of energy.
But
We
you
can-
can see that with the light, no?
Listen to what I'm saying. Release of energy can occur in 2 ways. The release of heat or the release of light. Okay? In a true combustion, you have the release of heat. In forming metal oxides, you have the release of light. Yes, you have the release of energy, but no, this is not a combustion.
But that's not what it said in the book though. From what I read, that's not what it
Because it's a release of energy. That is why they're classifying it as a combustion, because you're releasing this energy in the form of light. But a true combustion needs to have a hydrocarbon.
But can we say that this reaction with combustion and combustion?
Number 6 is not a combustion.
No, it is a combination.
So the lab manual is wrong, is what you're saying.
It's how you explain things. And the way Dr. Miller's explaining it, it's bringing 2 things together to make it easier for you guys to classify things. However, if you simply look at I think it's confusing too. But if you just look at magnesium, the chemical equation for magnesium and oxygen gas, the result is what? What's the product? Magnesium oxide. What does that fit under?
combination.
A combination. So if you did not know that there was a releasing light, what would you label that reaction as? A combination.
Decomposition. Can we go over first reaction in lab? It was a double replacement or decomposition?
Both.
Red what?
First reaction.
It was a what?
It's both.
What happens if you only put it with one?
Well, then that means your discussion is not thorough.
It was both. And how can you have two different?
So which one?
Y'all done took up 45 minutes of my lecture up here. I know
Why are
that.
you supposed to have, how do you have two
What are you decomposing though? All right, bet. What are my two products that form? How I taught you. What are my two products that are formed?
In order, decomposition.
Water and carbon.
No, that's not how I teach you. The first one.
The product was carbon dioxide.
No.
Which one?
You
The
mean
first
if we
one?
work it out without doing it in the lab?
Yes.
Okay, it was H2CO something.
Don't tell me no H2C or something. What is that?
I just told you.
No, you did.
Because you said break it down. I had H2CO3.
What is that?
It's
Carbonic acid.
Carbonic acid
Oh,
and
there you go. You can have carbonic acid and sodium chloride. As chloride. What?
Chloride.
Chloride.
there you go. Sodium chloride and carbonic
And then
acid.
you said
Acid.
you said it's created into carbon dioxide and water and sodium chloride.
Sodium chloride stays,
Yeah, but the
right? So your carbonic acid,
sodium carbonate? No.
your carbonic acid, something happens with your carbonic acid. Carbonic acid is very unstable. All right? So what did you see in the lab?
Water.
No.
Gas.
Wait.
You saw gas being produced. How were we able to identify this gas? This splint. What happened to the splint?
It's out when we put it in.
It out. Why did it out?
There's no oxygen support to.
Tell me again.
It doesn't support.
Well, don't tell me no it. What is it?
Carbon dioxide.
Carbon dioxide does not support combustion. All right? So you know for a fact that carbon dioxide is being produced. So if you have carbonic acid, H2CO3, and you pull out carbon dioxide out of that, what do you have left over?
Oh, yeah, you gotta do the vision.
You have H2CO3.
Carbonic acid.
If you pull out or you subtract carbon dioxide out of there,
Water.
you have water. So carbonic acid is highly unstable. So therefore it decomposes to water and carbon dioxide.
Okay, I see what you're saying.
So it's carbonic acid anhydrase CO2.
What?
Carbonic acid anhydrase, is that CO2 because it's without the
You gonna make me just.
It was a reach.
No, that
I didn't reach for the
is.
stone so long
You're not even left field. Left field is a dot to you. With that one, a dot.
Don't you like that?
Huh?
You don't like that? You don't like
No, that ain't no kind of effort right there. No kind of effort.
Wait, alright, so sodium carbonate in the first reaction was a solid.
Yes.
When I observed, there was still a solid substance.
No.
The fizzing was there.
That's not solid. What does fizzing mean?
The formation of gas.
Right.
Okay, so my carbonic acid should be aqueous.
No, carbonic. Oops, what? Yes.
On the product side.
Yes. What else? Anything else? Yes, no, maybe, however. Okay. So we are going to continue with our. Do we see it? Nothing? Ooh, I see it. There you go. So continuing with our molecular formula, calculating the molecular formula from the empirical formula. Here's another one for you. A compound shows to be 94.1% oxygen and 5.9% hydrogen. Determine the molecular formula of the compound if the molar mass of the compound is 34.02 grams per mole. This I'm cussing.
Can't see.
Where's your glasses?
Forgot them. I was gonna be late if I went back.
Shameful.
Had to get homework.
Hmm?
94.2.
94.1.
Maybe 4.1 is
Made any?
Bigger.
No.
5.9 is hydrogen. And the molar mass is 34.02.
How you figure that? What'd you do first?
I make the percentage to gram.
Link the percentage to grams.
Yeah, then oxygen divided by 16, and divided by 1.
So we get,
5.88 and oxygen.
there you go. So what do we do next?
Then we divide by 5.88.
You divide by 5.88 and what you get?
1, 1.
You get 1 and 1. So that empirical formula is H and O. Alright? So what's next?
Then we have the N. So O is the empirical formula's mass is 17.
Mass is 17, good.
And we got E gives the 34.
Mm-hmm.
Then 34 divided by 7 is 2.
Find your N. What do you do with your N?
Multiply by OH by H is 2.
Multiply. You get H2O.
I have a question. Like,
Yeah.
it's a matter like if I put like H
Yes.
O or OH.
Yes, it does.
How I know that I have to put OH for it.
How I have it set up in the equation, normally, that's how I want it set up. I know this one is flipped. I know. Right? But normally, you would set it up the equation the way how it's given to you in the question.
Oh.
Right?
Can you please go down one step?
What do you want to do? Shouldn't you know what you're doing?
No.
Yes. What's the first step?
Sorry, percent to mass.
Percent to mass. So set that up. What do you have?
That's when the empirical formula is given, right? We have to find the molar mass from the empirical formula. Is that
For
what
which one?
For the hydrogen peroxide.
Well, what part are you talking about?
The last one.
I can say, but I don't know you like
No. You do it, Noreen. Come on now. Muhammad is not going to help you on the exam, so you have to be able to do it.
I don't want to lose my paper again.
Tell me again?
For the hydrogen peroxide, right?
Yeah.
Given the empirical formula, you want us to find the molecular formula?
No,
Because
you
give us the
found.
hydrogen.
I gave you the percentage of each atom. Don't try to blind me with your flash!
Sorry.
Right? So, once I give you the percentage, you're going to convert your percentage to mass. Then you convert your mass to moles.
And then get the empirical formula from there.
How do you get the empirical formula from there?
Divide everything by the lowest.
Divided by the lowest, and that gives you your empirical formula.
Unless
Then-
we can't round, then we have to do that extra step. Unless we can't round, and then we have to do that.
Right.
extra step. Okay.
Right? Once you do that, you find your empirical mass.
Which was 17 grams.
Right.
And
Then you find your magic number.
you already gave us the molecular mass was given. Okay.
Yes.
And then you divide that and then multiply again.
Yes.
I thought you had to find the empirical formula first, but you don't.
You did? That's what you found first.
Wait. I thought you find the empirical formula by multiplying the percentage, well, when you turn it into grams. The empirical formula, right? We're gonna do these steps here? No.
Yes?
Yeah, but when did we do that? Because I don't see none of that. Oh, so you do have to do that first.
Yes.
I'm doing that. Oh, let me go back. But then I seen that step, so I thought we didn't have to do it.
Okay. So now, we're getting into the good stuff.